Good morning, kiddos. Today we're talking about 2.2, inductive and deductive reasoning. And we have a ton of definitions to get through, so let's go ahead and get started. Our first definition is conjecture. And conjecture is an unproven statement based on observations. So since you guys have only seen me here at school, you could assume that I live here at school. Our next term is inductive reasoning. And inductive reasoning is finding a pattern and then writing a conjecture. And remember that a conjecture is an unproven statement based on observations, okay? So we know from last year in person that Mr. Flo likes to walk around the building, okay? So that is a pattern, and we can form a conjecture saying that Mr. Flo walks around the school every day. Our next term is a counterexample. And a counterexample is a specific case that shows the conjecture is false. Okay, so conjecture is an unproven statement based on observations, okay? So if we look around the math department here, we can see that there are a lot of female teachers, okay? So you could make the conjecture, the unproven statement based on observations, that only women teach math here. Okay, but a counterexample is something that proves that conjecture false. Okay, so we could say that Mr. Todd is a male math teacher here, or Mr. Matheson is a male math teacher here. Both of those would be counterexamples to the conjecture that only women teach math here. Our next term is deductive reasoning. And deductive reasoning uses facts, definitions, accepted properties, laws of logic, and to form a logical argument. So we could use that congruent angles have an equal angle measure. And we know that by the definition of congruent angles. Next, we're going to talk about something called laws of logic. And we have two laws that we're going to be talking about today. Our first law of logic is the law of detachment, and that is defined by if the hypothesis of a true conditional statement is true, then the conclusion is also true. So let's do an example of that right now. All right, so here are our two statements for our first example of law of detachment. We have Michael Jordan is better than any other human at basketball. And our second statement says that Mr. Ingram and Michael Jordan are going to play a game of basketball. All right? So if we assume the first one is true, that Michael Jordan is better than any other human at basketball, and we know that Mr. Ingram is a human, then that means that Michael Jordan is better than Mr. Ingram. And that's our conclusion. So what's going to happen if Mr. Ingram and Michael Jordan play a game of basketball? Michael Jordan is going to win the game, or he is going to be better than Mr. Ingram. Okay, so I'm going to write down our conclusion. So I wrote our conclusion, Michael Jordan will beat Mr. Ingram at basketball. So the way that I remember law of detachment is that you have to write your own conclusion. So the law of syllogism says that if we have a hypothesis A, then that will lead us to our conclusion B. So if A, then B, okay? And then we have a second statement that says if B, then C. So B is now our hypothesis, and it leads us to another conclusion, okay? Then if both of these happen, then we can skip the B step and just go A to C. Okay, and this is a little hard to see with letters instead of actual words. So let's do an example of this. Okay, so here's our example. The first statement, that A to B, says that if you go to a restaurant, then you will order food. Okay, so let's underline our hypothesis and conclusion just to see where they are so that we can move from A to B and then B to C, okay? So here, our hypothesis takes place after the if and before the comma. So our hypothesis is you go to a restaurant, okay? And then our conclusion happens after the word end and to the end of the statement. In this case, it is you will order food, okay? So A is in red and B is in blue, okay? Okay, so we went from if A in red to B in blue, okay? In our second statement, our hypothesis is if you order food, okay? After the word if and before the comma. So our hypothesis is you order food. So we're going from that same you will order food, B, and then your conclusion is after the word then and to the end of the statement. So here it is, you will eat. Okay, and that's going to be our C. So in our first statement, we went from A to B, our hypothesis to our conclusion, and then we used the same conclusion for the first one as our hypothesis for the second one, and led us to a different C conclusion, okay? So from A to B, and then from B to C. What we want to do is we want to go from A to C. So we're gonna completely cut out that step that says you will order food. And that's gonna look like if you go to a restaurant comma, then you will eat. Okay, so we use the same hypothesis for A, you will go to a restaurant, and the same C conclusion, you will eat. Okay, so I remember law of syllogism from A to B, B to C, and we want A to C. All right, so let's do an example. Over here I have two statements, and we have to pick whether these lead to a law of detachment or a law of syllogism, okay? So the first statement says that if two angles are vertical angles, then they are congruent. And the second statement says you see that angle 1 and angle 2 are vertical angles, okay? So for this one, our conclusion is going to be that since angle 1 and angle 2 are vertical angles, then they also are congruent. So our conclusion is angle 1 and angle 2 are congruent. Okay? And since we had to come up with our own conclusion here by piecing together these two statements, this would be a law of detachment. Okay, this example, we again have two statements and we're trying to decide if we're using law of detachment or law of syllogism. Okay, so this says if you run for president, then you are at least 35 years old. And if you are at least 35 years old, then you are not a high school student. Okay? So I know this is law of syllogism right here because we have that repeating B statement that says you are at least 35 years old. Okay? We went from A to B and B to C. So we repeated that B, and that's how I know that it's law of syllogism.